안녕하세요. 저는 아카시입니다. 수학교사예요. 반가워요. Well, I tried my introduction in Korean. So I was like, 안녕하세요. It means like hello in Korean. And 수학교사예요. I'm a max teacher. And 반가워요 means like nice to meet you. Something like that. I tried my introduction in Korean. Now let's come to the question. If a ray makes angles alpha, beta, gamma, delta with the four diagonals of a cube, we have to find out cos square alpha plus cos square beta plus cos square gamma plus cos square delta. Okay, now here is our cube. This is something I took it from the textbook. I mean, I took it from the textbook means in the textbook this is how it is given and I used the same thing. Okay, now the cube we are taking in such a way that our calculations become easy. See the logic, see, so that our calculations become easy. So one of the vertices of the cube, let it be origin, let one edge be along x-axis. So capital A is, so edge OA is along x-axis, edge OB is along y-axis, and edge edge OC is along z-axis. Fine. Now, and if you see this point D is in xy plane. D is in xy plane here. Okay, so on that note, I'll just give its coordinates also. What will be capital A? See, it is a cube of side A, cube whose length of side is A. Then what will capital A be? So this will also be A, like OA will also be A. We know that in a cube all the sides are equal. I mean all the edges, lengths of edges are equal. Fine. So lengths of these are equal. So capital A is going to be A00. Fine. What will be capital B? Capital B is on x-axis. Capital B is on y-axis. On y-axis, it's going to be 0 B0 because x and z are 0. So 0, I'm sorry, 0 A0. I think I need to warm up a little. Sorry for the mistakes I made till now. I'll be more focused. Now capital C is on z-axis. On z-axis, x and y coordinates are 0. So C is going to be 0, 0, A, 0, 0, A. Now D is in xy plane. D is in xy plane. This is A and this is also A, distance. Okay. So D coordinates are going to be, it's in xy plane. In xy plane, Z is 0. So D is going to be A0. Fine. And next E. E is in xz plane. E is in xz plane. So E is going to be A0A. And G is in YZ plane. So G will be 0A0, 0AA, YZ plane, right? So it's going to be, X is going to be 0. And F is not in any, F is somewhere outside, okay? It does not lie in any of the planes totally. It's a point in space, okay? So F is going to be AAA. F is going to be AAA. Fine. Now whatever I told you, the theory is there in the next slide. Let O be one of the vertices of the cube, be taken as origin, and the three co-terminus edges OA, OB, OC as coordinate axis. This is what it means. OA, OB, OC be taken as coordinate axis. Now next, let OA equal to OB is equal to OC is equal to, yeah, I told, right, let the length of side of a cube, like I mean one of the edges of the cube, let its length be A. So what are the diagonals? If you see the diagonals, one diagonal is OF, from O to F. Draw it. It may not be that good if you'll connect it. If I'll draw it, it will become a bit clumsy if I'll draw, but still if you want to see. O and F, this is one diagonal. Next diagonal will be AG, like this. AG. It will be good if you can imagine, see what you can do now, you can imagine your room to be a cube. If you'll imagine your room to be a cube, now you can connect like from this corner of the room to that corner of the room. Next, for B it's going to be E. Okay, for B it's going to be E, and for D it's going to be C. So the four diagonals are OF, AG, BE and CD. Fine. This means a line segment. Okay, the top, the bar you are seeing, it means a line segment. Now, the coordinates of the vertices. This I already explained. O is 0, 0, 0. It's origin, right? O is 0, 0, 0. So its origin, and this is A00, 0A0, 00A, and vagera vagera. I already explained to you before. Now let's come to our question. This was introduction, like we did not do anything related to the question up till now. Now, if a ray makes angles alpha, beta, gamma, delta with the diagonals of a cube, if that is the case, then we have to find out cos square alpha plus cos square beta. Fine. So there is a ray which is making angles with 4 diagonals of a cube. Okay. Now in DC's DR's topic, if we need some information about the ray, right? See, for the 4 diagonals, now for the 4 diagonals information is available. I know the 4 diagonals, okay, but about the ray I do not know anything. They told that the ray makes some angle with some angles with the diagonals of a cube. Let me consider the ray makes alpha with OF bar. Okay, let's say the ray makes angle alpha with OF bar in my diagram. Okay, see, OF is one diagonal and the ray makes alpha with this diagonal. Fine. OF DCs I know, I can find out. I can find out OF DCs. See, to find out angle, na, I need to find out cos alpha. To find out cos alpha, I'll either need DCs or I'll need DRs. Better to use DCs in this case. Okay, better to use DCs in this case. So on that note, I'm about the ray. I'm going to take its DCs as LMN. Okay, for the ray, take the DCs as LMN. So let small n be the DCs of the ray which makes angles alpha, beta, gamma, delta with the diagonals OF. Okay, well, alpha is the angle which it makes with OF, beta is the angle which it makes with AG, gamma is the angle which it makes with BE, and delta is the angle which it makes with CD. Fine. Now next. And since these are DCs, what is the property of DCs? If like LMN are the DCs of a ray, then we know that L square plus M square plus N square is 1. Remember this. If for a ray DCs are given, the DCs will satisfy. L square plus M square plus N square is 1. DCs means what? Direction cosines. Now from here on it's kind of easy. See, first find out DCs of OF. See, to find out cos alpha is what? Alpha is the angle between our ray and diagonal OF. Fine. So I can find out cos alpha very easily. To find out cos alpha, I'll need DCs of diagonal OF, and I'll need DCs of the ray. DCs of the ray are already known, LMN. We assumed. Okay. Now I need to find out DCs of OF. To find out DCs, I need DRs. Okay. Now what is O000? What is FAA? DRs are nothing but x2 minus x1. See, remember, DRs of a line segment or ray. Okay, they are given by x2 minus x1, comma y2 minus y1, comma z2 minus z1. DRs. Okay, so OF, right? So see these two. O is 0, 0, 0, F is A. So x2 minus x1. So A minus 0, A minus 0, A minus 0. So my DRs are AAA. Fine. Now next, I need to find out DCs. To find out DCs, what you need to do is you need to divide the DRs, like the three in the DRs, by under root of A square plus A square plus A square. DCs are nothing but A by under root A square plus A square plus A square, and A by under root A square plus A square plus A square. The sum of squares of these, like under root of sum of squares of these, with that you have to divide. Right? What is under root of A square plus A square plus A square? It is under root of 3A square. Fine. Under root of 3A square or root 3A square. Let's see, root 3A square. Root 3A square, I can write it like root 3 into root A square, and root A square is A. Now A cancel. So the DCs of diagonal OF are 1 by root 3, 1 by root 3, and 1 by root 3. Now next, stay focused. I know it might be a little boring, and I'm not that. Nowadays I'm like a bit busy, and I think I'm not able to make many videos as well, but still I hope You would enjoy this. I know I'm fumbling a bit. I know I'm, sort of not up to the mark, because it's like I just got some time and I'm making it. PPT is there, so I won't be making much mistakes, but I might go a little here and there while I say. Please do forgive me for that, but PPT is correct. Now, alpha is the angle between the ray and OF bar. Fine. Now, the DCs of the ray are LMN. What is cos theta formula? Cos theta formula is mod L1 L2 plus M1 M2 plus N1 N2. Okay. L1 M1 N1 are DCs of first ray, and L2 M2 N2 are DCs of diagonal OF. So L into 1 by root 3 plus M into 1 by root 3 plus N into 1 by root 3. So L by root 3 plus M by root 3 plus N by root 3. So L plus M plus N by root 3. And it has mod. In mod L plus M plus N by root 3. They're asking in the question, they're asking us cos square alpha. So just do cos. So cos alpha is this, right? So cos square alpha, you can eliminate the mod because you're squaring. You need not bother about mod. So you would get cos square alpha is L plus M plus N whole square by 3. Now let's find out the beta is the angle between, if you remember, I took beta is the angle between the ray and AG bar. So one more thing, and you can just write similarly. So the DRs of AG, diagonal AG, A is small a 0 0, G is 0 A. So DRs of this will be 0 minus A minus 0 and A minus 0. I told, right, A minus x2 minus x1, y2 minus y1, z2 minus z1. So on that note, what I'm going to get is DRs of AG are 0 minus A minus 0 and A minus 0. So minus A comma minus A comma A. Minus A comma A. Again I'm fumbled. Sorry for that. Had a hectic day. Little hectic it was. Now next. DCs, right? DCs will be minus 1 by root 3, 1 by root 3, 1 by root 3. Like right? See, divide this by under root of minus a whole square. I'm not showing it because already we did it in detail for first time. So this is going to be root 3a square and this is going to be root 3a. So minus a by root 3a would be minus 1 by root 3 and 1 by root 3 and 1 by root 3. So DCs will be this. You can, for detailed process, you can just refer to this, how this came. In the same fashion, you will get this for this also. Fine. Now, cos beta is the angle between the ray and AG bar. So cos beta is L into 1 by root 3 plus M into 1 by root 3 plus N into 1 by root 3 minus L plus L by root 3 plus M by root 3 plus N by root 3. Again, cos square beta is going to be minus L plus M plus N whole square by 3. Now you can just write similarly. See guys, observe the logic. For A, minus came here, minus L plus M plus N. For B, cos square gamma is going to be L minus M plus N. And for CD, for that you would get a minus here, L plus M minus N whole square by 3. Hope it's clear. All that's left is simplification. We already got its value. See, cos square alpha value is there in the previous slide. This is cos square alpha, and the next one, this is cos square beta and cos square gamma and cos square delta. Now just simplify this. Okay, if you'll just expand it and do things now, it could take a little, it would be tough. If you will tell, sir, I will use a plus b plus c whole square and do it. Okay, do, that's fine, but it will be little hectic. And let's try to use some techniques. See, there is a property from algebra. What is that? Is not exactly a property. You learned, right? A plus b whole square plus a minus b whole square. A plus b whole square plus a minus b whole square is nothing but 2 times a square plus b square. Okay. It's nothing but 2 times a square plus b square. So I'm going to use this. How? See, if you'll observe the first term and the fourth term carefully, here I have L plus M plus N, here I have L plus M minus N. So if you will consider this as A, if you will consider this part as A and this part as B, here I have this part as A and this part. So this is of the form a plus b whole square and this is of the form a minus b whole square. So I can apply this condition, a plus b whole square plus a minus b whole square is 2 times a square plus b square. Okay sir, super, we can apply this here, but what about the remaining two center ones? What to do? What to do? For that, what I'm going to do is, see here I have L minus m plus n. Here I have minus L plus m plus n. So for this, what? In the second term, you have to do a small change. In this, take minus common. In this three terms, take minus common. So this I can write as minus of L minus m minus n whole square. Okay, minus I took common. Now minus is there outside, but square is also there. So square will take care of the minus, because minus square is going to be positive only. So I'm going to get this. Okay, and this is nothing but this, I wrote it here. The last term, the fourth term, I brought it to the second. This third person is there as it is, not a person. The third term is there as it is, and this one has come here. Now, if you observe this, this if you'll consider as A, and this if you'll consider it as B, this if you'll consider it as A, and this. So this is of the form A plus B whole square plus A minus B whole square. Now see it. I took 1 by 3 common. All of them have the same denominator, so 1 by 3 I can keep it outside, and a square bracket, and have this. This is what I have. Now, as I mentioned, this plus this one square plus this one square is going to be 2 times a square plus b square. A is what? L plus m whole square, and b is n. So this two terms would give me 2 into L plus m whole square plus n square. Fine. And these two terms will give me 2 times L minus m whole square plus n square. Okay, fine. Because you can see it like this, something like this, L minus m plus n and L minus m minus n. Okay, so a plus b whole square plus a minus b whole square. That's what I'm repeating it over and over again, because for you to understand better. If you feel it's boring, it's okay, what can I do? But I want many people to understand this. For that purpose, I go a little slow and I repeat things, so that things go, so that anyone, I cannot say anyone, at least most of you can understand what I want to convey. So this one is 2 times L minus m whole square plus n square. Now next, just multiply 2 into L plus m whole square plus 2n square plus 2 into L minus m whole square plus 2n square. Okay, now again see this term and this term, see this term and this term. This is 2 into L plus m whole square, this is 2 into L minus m whole square. I can take 2 common in these two terms. Take 2 common. 2n square plus 2n square is 4n square. 2 into L plus m whole square plus L minus m whole square. Again, this is of the form a plus b whole square plus a minus b whole square. That's going to be 2 into a square plus b square. So here I'm going to get 2 into a square plus L square plus m square. 2 is already outside 1, 2. So 2 into L square plus m square. 2 into 2 is 4. So 4 into L square plus m square. Multiply 4 into L square. 4 into m square. So 4L square plus 4m square plus 4n square. Take 4 common. 4 by 3 into L square plus m square plus n square. 1 by 3 was there since the beginning. Now I told you in the beginning, L square plus m square plus n square is 1. So that's it. So cos square alpha, in the end you can write therefore, in the end you can just write therefore cos square alpha plus your favorite statement, everyone's favorite statement, cos square gamma plus cos square delta is nothing but this gamma is equal to 4 by 3. Hooray! We got it. It feels nice, right? Always to end something. I hope I didn't bore you too much. If you felt bored, cannot do anything much, you could have seen it at 1.25 speed or 1.5 speed if you felt it was kind of boring. I know I fumbled a little. I know I did not prepare that well. I just made that well, so that's why I got stuck a little in between. Well, anyway, sorry for that, but PPT is correct. So if you just write how things are there in the PPT, you should not have any problem in getting good marks. And thank you.